Hello everyone, and welcome to this live cooking show where we're gonna see natural dyes and bio dyes. So this workshop is part of the Planetary Thinking Ecological Crisis theme of the festival. This topic is completely aligned with my research creation addressing the polluting aspect of the textile and the fashion industry. As you probably know, fashion is one of the most polluting industries in the world, and synthetic dyes are part of this issue. So many scientific studies have shown their toxicity and negative impact on health. So we're going to discuss how to make a natural dyes to find alternative to this toxicity. Let's start by giving you a little bit of context. I'm particularly interested in this issue because I've been working in fashion for 20 years as a textile designer. And color is therefore my main tool to express ideas. And as such, I became really interested in sustainable pigments. Natural dyes usually requires a lot of water and cultivable lands. So I was rather interested in repurposing something already there. I was really inspired by the concept of cradle to cradle from William McDonough and the chemist Michael Braungart. So I started to look at waste and food waste as a potential resource to develop local dyes. So as you can see on the pictures, avocados, onions, or here on the tables, black beans, red onions versus yellow onions, red cabbage, and a few different examples like that. I had also a look at various researchers and designers' initiatives around the world. For example, the Atelier Luma in France is developing local dyes from invasive plants, algae, or agricultural wastes, for example. This approach of looking at local resources is also part of a bigger picture called Fiber Shed and developed by Rebecca Burgess. The idea is, consists of producing garments from soil to soils. So the interest here is to look at the local resources to produce color. So which kind of food waste could we use to create colors? You have to know that each ingredient is going to give you a specific shade. And later you can modulate this shade by modifying the pH of the bath and keeping it more acid or alkaline. So now we're going to discuss the choice of the fibers. As you can see here on the image or on the table, according to the fibers you are dyeing, you get different shades. Like for example, protein fibers from animals are getting brighter shades, brighter hue, like silk or wool. And cellulosic fibers like linen or cotton are going to get lighter shades. What I advise you to do when you start dyeing with natural dyes is to keep a recipe book, to keep record of everything you do, to keep track of your test, in order to be able to reproduce your colors, because dyeing a fabric is quite easy, but reproducing the right shade is quite tricky. So you have to keep in mind, you have to note the weight of the waste you're gonna dye, the waste of the fabric you're gonna dye, to be able to make this shade again. You also have to note the type of mordant you're gonna use. Mordant is a bath made of alum. The alum is what I use, but you get a lot of good ideas on the website of Maiwa, for example. Gives a recipe of different mordants from alum, or according to the protein fibers or the cellulosic fibers, you're going to get different recipes. So once you get your different waste, we're going to start to make decoction. So ideally today I wanted to cook live with you, but because it takes a bit of time, I prepared all the decoction today, as you can see on the screen, and I'm going to explain you the process. So here is the first recipe. The first thing is to gather the right amount of food waste. Every time I cook, I gather my waste, I ask my neighbors, but also, when we want to get bigger scales, maybe ask local restaurants, groceries, or create collaboration with different companies to gather the food waste. So for the first dye we're gonna make today is made with onion, and particularly yellow onion dyes. For this one here, for this kind of amount of fabric, I used 4 liters of water in a stainless steel pot. This is very important because if it's not stainless, it can affect the color of the dyes and you won't get as bright a color. It's also important to keep a track and check the water pH. So water usually is medium, 6 pH. And what I did for this amount of fabric, I finely chopped, so you can, you know, when you chop your fiber, your dyes, you get brighter colors. So I chopped 50 grams of onion skin in, and then I put them in cold water. Then I bring that to boil, and I cook it for 1 hour. And to get the maximum pigment out of the skin, I let it cool down and stand overnight. And the following day, I filter and press in a fabric. I really press the onion skin very hard to extract the maximum of pigment. Then I put the wet pre-mordanted textile in the bath. What I call pre-mordanted textile is the day before or even weeks before. You can dig, as Maiwa recipe, you're gonna check on their website, but you dip your fabric in this mordant and then you let it dry. And right before to dye, it's very important to wet it again. So you put your wet pre-mordanted textile in the bath. You cook it for about an hour, and then you let it cool down overnight. You rinse it well, you dry it away from the sun, and then I advise you to wash it with a gentle soap only a few days after to keep the maximum of shade. But onions really hold a very strong tannin and keeps the color very hard on the fabric. It's not really, it has a very good light fastness, and it's it stays on fabric very well. Here I gave you an example of another recipe. For example, I scale up the recipe. I was dyeing 3 meters of fabric, 10 foot of wool jersey. So for this amount, I put 30 liters of water in a huge stainless steel pot, and I use 320 grams of onion skin, which is quite a lot because onion skins are quite light. You have to be aware that to warm up all this huge amount of water, it takes up to 4 hours to reach boiling points. Then you cook it for 1 hour, and the same process, you let it cool and stand overnight, filter it, and use it as a bath. All the recipes are a bit the same. Like, for example, avocado, onions, you have to boil the ingredients for about an hour. Here is the one I used here for this amount of fabric. Also, I used 4 liters of water. What is very important is to allow enough water, enough space for the fabric to move freely. Otherwise, it's gonna stain your fabric. So it's why I use more water that I really need it. You can also use twice your bath. Like the first bath is gonna be darker, and then more you dye and lighter is getting your bath. And then it's the same recipe. Here we see, sometimes people are surprised. How come I get pink shades when I dye with avocado, which is green at first? It's because avocado holds a red tannin, and here we can see it on this picture. As you notice, sometimes when you cut the pit or your avocado, you get these pink shades on it, so it's this pink pigment that is gonna dye your fabric. While you're cooking the fabric, you have to mix it constantly. I mean, quite often to avoid stains and to dye it evenly. So I was talking about warm and hot techniques. Here, concerning black dyes, I'm using the soaking water of black beans. The dye is cold, so you leave it overnight. You put before to cook your big recipe of black beans, you leave it overnight, and then you filter the following day. And what I add a little bit is a bit of iron, but the iron you take, as a supplement, a food supplement. So I put a little bit of iron, and then I leave my fabric overnight in this bath. And here I got this beautiful different shades of blue. And according to the kind of beans I use, sometimes I can get some blacks or grays. It depends. It can vary the shades. What is fun also when you dye with natural dyes is you can modulate your colors by changing the acidity or the alkalinity of the bath. So here on the example, I was modulating my fabric that I dyed with grape. So grape is very sensitive to pH. Like for example, onion and avocado are less sensitive, so you cannot modulate them as much. But in the case of grape or red cabbage, they are very sensitive to pH, so you can have a lot of fun. And as you can see on the image, you can vary the shades by getting blue. More you get alkaline, so it means it's a pH above 6, 8, 9, 10. You will get blues, grays, and green. And if you get more acid, like -2 alkaline, -2 of acidity, you will get more pink, bright pink, reddish colors. So here we can see the transformation of the grape decoction I made. And by adding some lemon, you get some brighter shades. So here we can see like more acid is pinker, and greener and bluer is more alkaline. And for darker shades, I use a little bit of iron too. So you can make your own modifier. You can use vinegar, but you can also use food waste to make your acid modifier. Here I use lemon, for example. So basically, you can use everything from the lemon. You can grate the peel and use the zest for a recipe. You can make juice and save it for your daily drink. And you can freeze your lemon peels. When you get enough, it's about 10 lemons for 5 liters of water I used for my recipe. But it can be less than that also. You boil it for 1 hour, and then you can keep it in the fridge for a few days, or you can freeze it for later use. And then you dip your textiles for a few seconds, and the change is instant. It's quite fast. And then thanks to this technique, you can play and extend the shades of your colors. At first you get a purple. Here the example shown here is with red cabbage. First it was purple, and then getting more pink with acidity, getting more blue and green with alkalinity and baking soda. The second technique I'm going to explain today is biodyes working with living organisms. Here I work with bacteria. These bacteria are naturally producing pigments, but we can extend the change of the pigments by modulating the temperature, the nutrients you give, and the colors are growing within 48 hours, so it's quite an interesting avenue. It grows in the lab, and it doesn't take that much water. So here again, what is very important is to keep track of what you do, which kind of nutrients, which kind of fibers you dye, how long you keep it, and in which environments, humidity, temperature, everything has to be recorded to be able to match it again. Here I also use for this technique food waste to make nutrients for the pigments. So I use apple peel decoctions, orange decoction, avocado, onions, so everything I have around to make a different test. And then the bacteria is growing on these different agars. Agar is extracted from algae, and is what is going to give the nutrients to the bacteria. So here I'm preparing liquid cultures with these different decoctions, and according to the acidity again, the sweetness or sourness of the bath, the bacteria is going to react differently. So here we can see a different test where I'm dyeing with different waste, but also different fibers. So this is the first day. I try with different linen, cotton. I try with avocado, beans, and then I check after 24 hours. And after 48 hours is the maximum dyes of the fabric, of the bacteria, what it can offer. So you get bright colors. At that stage, the bacteria is still alive. Then you have to autoclave it to kill the bacteria and get the shade you want. So here you see the variation of colors is mostly because of the difference of fibers. On wool, I get dark shades of red with onion, for example, while on silk I get brighter pinks, and on cellulosic fibers like cotton or linen, I get light purple colors. So I was interested in trying to extend this color palette a bit more. So I started to mix the decoction of food waste and the bacteria. Also, what is interesting when you work with living organisms is to observe their behavior. Here, for example, by working with it, I noticed that bacteria likes to be constrained in tight spaces. So by building and by making stencils, I was able to guide the growth of the bacteria and to produce prints, to print on the garments. So here, for example, we can see I prepared a black agar made with black beans, and then I put this stencil on the top and I applied the bacteria. And after 48 hours, I get all these bright colors that could give the pattern I was looking for. This pattern was inspired by this movement, the zigzag movement commonly used in microbiology to inoculate plates. And here we can see a piece of clothing I dyed and I printed. I dyed with avocado dyes and I overprinted using bacteria. So the bright red color is when the bacteria is still alive, and after autoclaving, according to the fibers the bacteria grown on, the red becomes a purple color. So what is interesting here is by mixing this food waste and this bacteria, I could get all the Pantone shades commonly used in the fashion industry. So I could really extend the palette. And so, yeah, that's it for today. I explained everything. You can also, if in the chat there are some questions, I could also answer to some of your questions. And also you can check on Instagram and reach me if you have any more questions. Thank you.